Think about this. We use electricity every day to turn on lights, charge our phones, and watch TV. We've been using it for over 100 years. But here's something surprising. Even the smartest scientists can't tell us what electricity really is. Sure, they say it's made of tiny things called electrons, but nobody has ever seen an electron. There's no microscope powerful enough to show us one. It's kind of like magic. We know how to use it, but we don't really understand what it is. Just like we don't know why things fall down when we drop them. That's gravity. We don't know why electricity moves through wires. We just know that it does, and we've learned to use it to power our world. All our pictures and descriptions of electrons are just guesses. Scientists' best ideas about how things might work. When we really stop and think about it, we have to ask, does electricity, as we imagine it, even exist? What is this energy that powers our world? And what hasn't modern science figured out yet? It's interesting that some scientists don't even think of electrons as real physical things. They can't tell us how big an electron is or what it's really made of. Yet these same scientists insist our world is purely physical. This is one of science's biggest mysteries. We use electricity every day, but we still don't truly know what it is. Think about this. Magnets are amazing things that we've used for hundreds of years. We stick them on our fridges, use them in compasses, and they're in many of our everyday gadgets. But here's something surprising. Scientists still can't explain what makes a magnet work. Just like with electricity, we know how to use magnets and what they do, but we don't really understand why they work. How does one piece of metal pull or push another piece without even touching it? Nobody can fully explain this mystery. It's just like electricity. We use these things every day, but their true nature remains a puzzle, even to the smartest scientists. Science doesn't know exactly what electric current is, and electricians cannot convince physicists otherwise. Let's discuss what is known and figure out what can be unclear in such a seemingly simple topic. According to the definition, electric current is the directed movement of charged particles. Current moves through a conductor, while ions at the points of the crystal lattice slow it down. A conductor is a substance, or if you prefer, a medium or material that conducts electricity well. The conductor contains a large number of charged particles that can move freely inside it, and under the influence of electrical voltage, create a conduction current. These charged particles, that is, electrons, move along the crystal lattice at whose points positive ions are located. And in the space between them, free electrons move. Here's a fascinating puzzle about electricity that even scientists struggle with. When we push something, Newton's laws tell us it should keep going faster and faster, accelerate. So when we push electrons with electricity, they should also keep going faster and faster, making the electric current stronger over time. But that's not what happens. The current stays the same. This makes scientists wonder, do the basic laws of physics work differently for electricity? And here's another mystery. We know there's no electric push inside a wire, yet somehow the electrons still move through it. So what's really making them move? These questions show us that even simple things we use every day still hide big mysteries. Question: is it possible to get electricity from the air? Let's remember Nikola Tesla, who was able to obtain energy from the atmosphere. He knew that with each meter up from Earth's surface, the voltage that exists due to Earth's electric field increases by 100 to 200 volts. Let's now look at a fascinating quote from the genius Nikola Tesla. Here's how he describes the existence of ether, which modern science does not recognize, and which was apparently removed from Mendeleev's table. I cannot believe in two electricities. The so-called static charge of a molecule is ether, connected to the molecule in a specific way. The rotation of molecules and their ether causes ether tension or electrostatic deformations. The equalization of ether tensions causes ether movement or electric currents, while the orbital movements of molecules produce the effects of electromagnetism and permanent magnetism. Tesla built a special tower several dozen meters high, with a laboratory set up in its upper part. Since voltage increases by 100 to 200 volts with every meter above the ground, at a height of 30 meters, his laboratory received a voltage of 3,000 to 6,000 volts of direct current without any generators. From there, this energy could be used for virtually anything. Of course, working with high-voltage direct current was quite challenging, as the suitable components for such applications only appeared in the mid-20th century. In 1905, Tesla filed a patent in the United States titled The Art of Transmitting Electrical Energy Through the Natural Medium, which outlined a series of generator projects around the world. These were intended to use the ionosphere to collect energy. He also considered the Earth itself as an electrical generator of limitless energy. Nikola Tesla built towers known as the Tesla Experimental Station in Colorado Springs and the Wardenclyffe Tower, or Tesla Tower, on the East Coast. These structures were designed to harness the Earth's energy field. The locations for their construction were chosen based on principles similar to those used in building the pyramids of Giza. The designs were intended for the wireless transmission of energy. It is also believed that the Tesla Tower was built above aquifers. This raises the idea that the ancient Egyptians may also have developed and built systems that utilized electricity. For example, Norman Lower studied ancient Egyptian sites and noted that no traces of burning, neither from torches nor candles, were found inside the pyramids. It is possible that the ancients used electrical energy for lighting. The exact purpose of the pyramids remains unknown. Mathematicians and physicists agree on one point. The pyramids could serve as a means of communication or as tools for accumulating and redistributing energy. But what kind of waves they used and how they operated is still a mystery. In conclusion, electricity, magnets, and the potential existence of ether challenge our understanding of the physical world and reveal the limits of modern science. Despite centuries of advancements, fundamental mysteries about the nature of energy and its interaction with matter remain unsolved. Visionaries like Nikola Tesla remind us that the universe might hold answers in places we've yet to explore or even imagine. Tesla's theories, combined with historical enigmas like the construction of the pyramids, suggest that ancient civilizations might have harnessed energy in ways we are only beginning to comprehend. These questions inspire us to keep pushing the boundaries of science, not just to solve practical problems, but to unravel the deeper truths about our world and its unseen forces. Who knows what discoveries await if we dare to look beyond what we think we know?